I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to Lesson 30. We are in our color unit. Cheryl, would you possibly have another question about color?
I do, Ryan. I actually have 4 more questions about color.
4, specifically 4. That's no more. You'll be done with color after 4.
Nope. No more follow-up questions or any further thoughts on color.
Wow.
I'm impressed. I guess we should have 4 more lessons.
Okay, we can do that.
Great. Well, this one to me reminds me of lesson 22.
Okay.
Where we talked about why my eyes are blue.
Okay, so we're going to talk about eye color again?
Well, I mean, we did talk about color, and we talked about how blue eyes aren't actually, like, there's nothing in them that make them blue.
Right.
It's just like the lack of melanin.
Uh-huh.
And then they appear blue. And in that lesson, I asked you, oh, that's why the sky is blue then, right? And you were like, well. And so I'm assuming that the sky is not blue from a lack of melanin.
I mean, I guess if the sky had melanin, it probably wouldn't be blue.
But now I'm very curious why the sky is blue, because now I know why the sky isn't blue. That's not the right way. This is not English class, Ryan. Don't get hung up on it.
That's fine. I just don't understand what you're saying. But this is like the question, right?
Yes.
Why is the sky blue? That's kind of a standard, stereotypical science question. What makes the sky blue?
Yeah. And I want to know.
Okay. Well, let's start with what you already know and what you already think. Clearly, you think it's related to melanin.
Yep. I'm so glad you understood me. I have been told before, I think on more than one occasion, that the sky is blue because it reflects the water.
Okay.
And the water is blue because it reflects the sky, which feels very much like a chicken and the egg thing of like, well, but why couldn't they be anything else if they reflect each other? Or why aren't they a void of nothingness why aren't they white if they reflect each other? Because then isn't that all the colors?
Oh, okay.
Like if there isn't color being added, like when you hold water in I know we're talking about the sky, but I think it's related. You hold water in your hand, it's just clear unless there's like a problem.
Unless there's something in it that shouldn't be.
Yes. Yeah.
Okay.
So then, but like the water's blue because it's reflecting the sky, but then like, why does the sky look blue to us? Is it just like the easiest wavelength for us to see?
Oh, interesting.
But like there's nothing in the sky because we're just looking out into our atmosphere, right? Is that what we're looking at? Well, on like a clear day, is we're looking up, but like we can't see. Well, no, because then we can see the stars at night. So we're looking out into like infinity when we look into the sky. It's just during daytime, there's a sun there, so you can't see the things out there. But like technically our vision, like there's nothing blocking our view from seeing to the stars.
I think I see what you're saying.
So we're not actually looking at anything. You know what I mean? We're not looking at like an object when we look at the sky.
So then why don't we see all of the stars during the day?
Well, because of the sun. So like that part makes sense because the sun's like way too bright. It's way too bright. And then like it washes everything else out.
Okay.
It just makes it so like, I mean, I guess it'd be the same reason why like in a city, you can't see the stars. There's just too much. The sun is the ultimate light pollution is what I'm trying to say.
Okay. Okay.
But then still like, that just means like we're looking at nothing in particular when we look at the sky.
Right. So why is it blue instead of black?
Or why isn't it gray? Because at nighttime it's black, but then with all the sunshine, wouldn't it just be like a lighter shade
A
of
lighter shade of
black?
black. Okay.
Some like gray. I
Okay.
mean, that's what we're used to here in Seattle
Yes, it is.
is a gray sky. Yeah, those are my thoughts.
Okay, so where do you think the actual blue color comes from then? You talked about what you think maybe it should be based on the explanations, but that doesn't match what we
Yeah,
see.
I think it's an illusion
What do you mean by that?
because, well, it's not actually blue. So whatever we're seeing is like, feels like our eyes are like playing tricks on us of some sort.
Okay.
Probably has to do with wavelengths because we keep talking about wavelengths.
You sound so disappointed about that. If it had something to do with wavelengths, how might it be connected?
Well, see, that's what I still don't totally get. Like, I understand the thing where if something is a color, all it means is like it's absorbing all the other wavelengths and bouncing that one back at you. But
Mhm.
why? Or like how is it that different things are absorbing
Mm,
different? And so like
okay.
even if it is the sky is like absorbing everything but blue and then bouncing blue back at us, like what about the sky makes it do that?
Gotcha. And you have no idea.
No, it's just air. Well, there's gases. Maybe the gases still like why do they do that? Even if it was like something to do with what's in the air. Yeah, I don't know. That's why this is the unanswerable question. No one has ever figured it out.
Mm-mm.
And that's why they
Never.
say it reflects the water.
Yep. Yep. Nobody knows. So that's the end of our lesson.
Okay,
Thank you.
bye.
No, I think we should be able to get an answer to that.
Amazing.
And as you thought, the answer to this does lie with wavelengths.
Okay. Well, I mean, at least I know the right category,
You
so I feel
do.
good about
That
that.
means you're learning things because I'm guessing you
Yeah.
wouldn't have mentioned wavelengths, a month ago.
No, I would not have.
So it does. It relates to wavelengths. But then you ask the really good question. You're like, but how or why? What is exactly happening with our eyes? And you did a lot of really good reasoning through observations that you've made to figure out, well, there's got to be something here and there isn't something there. And so I want to kind of work through some of that to try and kind of build the whole picture together for you.
Okay.
So, like you said, when the sun's up, we can't see all the other stars, but at night when the sun's down, we can. So that's definitely a factor. The sun is definitely factoring into it somehow. But it's not just the sun on its own. And we know that, and I don't know if you've ever seen this, but we have pictures from when people have been on the moon during the day of the moon when the sun's up and they can still see the night sky and all the stars. I don't know if you've ever seen pictures like that.
No, but that's really cool. So it does have to do with our
It
atmosphere.
does. The
Okay.
atmosphere makes a difference. And at night, the sun isn't there, so the sun can't do whatever it's doing to the atmosphere, which is why we can see it. But during the day, the sunlight interacts with the atmosphere. And you're like, yeah. And you kind of talked a little bit about pigment because we talked about that last week,
Yeah.
right? How pigment, for a lot of the things we talk about, gives things color. And that's true. There is no pigment in the sky. So there's a different process going on. But the concept is still the same. The reason we see colors is because light of that color has to enter our eye somehow.
Mhm.
It's almost like you don't believe me.
I believe you. I'm just interested to see where you're going with that.
So that means you thought that maybe it was an optical illusion. It's not an optical illusion. There's actually blue light entering our eyes.
Okay.
Go ahead.
Well, I just think all of color is an illusion at this point in our series, but that's fine.
Well, I mean, I suppose you could make an argument that all color is an illusion because technically what we experience as color is something that our brains have interpreted. And so in that sense, I suppose you could classify all color as an illusion. But if we talk about color as in the specific wavelengths of light, that's not an illusion. That's an actual physical phenomenon.
Fair.
So we know that there must be something with the sun and the atmosphere that leads to blue waves of light reaching our eyes because we see blue when we look up at the sky.
Yeah.
Is making sense so far?
Yeah.
So then the question is, what's happening in the atmosphere? Well, the blue light, where do you think, big picture, where does whatever causes the light to be blue, where does that light originate from?
The sun.
Yes. And
Okay.
what color is that light when it leaves the sun?
Well, sunshines are yellow.
Okay. Sunshines are yellow.
Uh-huh. What color is the light when it leaves the sun?
Yeah, and think back to when we talked about rainbows.
Oh, it's all the things.
It's all the things. And what color do we
Yeah.
see that all of the colors as?
White.
White. So the
Yes.
light that leaves the sun is white. And we'll talk about the yellow in just a minute since you brought it up. I wasn't going to go there, but you brought it up. So we'll get back to the yellow part in just a minute. Okay. But so we know that the original light is white. So something is happening to make it look blue when it interacts with the atmosphere.
Yeah.
Okay. And we've talked about this before, but I'm going to say it again. Remember that the different colors have different wavelengths.
Yep.
Right? And you mentioned it. It must have something to do with wavelength, and it does. Do you remember which wavelength, the larger ones or the smaller ones, are on the blue side of the spectrum?
You've asked me this before, and I didn't remember last time, so I'm going to say long.
You had a 50-50 chance.
Yeah.
It's the shorter wavelengths.
Oh, man. Okay.
Maybe next week we'll ask again.
We probably will.
So yeah, it's the shorter wavelengths are the blue, the longer wavelengths are the red side. Good.
Okay.
You're nodding, so I think you're tracking with me, okay?
Well, here's my new mnemonic device.
Okay, yep.
To remember this.
Yep.
And it's silly.
It's okay.
Is so longer wavelengths are for the warmer colors.
Mm-hmm.
And so after they get baked in the oven, they need more heat or like more longer light wavelengths.
Okay.
Then they get warm colors like baked goods.
Okay.
Mm-hmm. They're warm.
Good. I don't see the connection to long, but I'm glad that it works for you.
The length of time in the oven.
Ah.
So longer
in the oven is longer light waves, and then they're warmer.
Yeah, and then they're warmer
colors. Okay.
Yep.
Perfect. You know what though? Those things work. Those sorts of mnemonics, and the weirder they are, generally the better they stick in our brains.
Yeah.
So good for you. So the different wavelengths of light interact with the atoms and molecules that are in our atmosphere differently. And there is something called scattering. And I'm guessing even separate from any sciencing thing, you know what it means to scatter something.
Sure.
What does it mean?
To divide and go like your separate ways or like move apart from each other.
Yeah, to move apart from each other. If you were to like scatter seed or something, you'd kind of like spray it out and it would go out in separate directions, right? All over the place.
Mm-hmm.
Light can scatter. It can go in different directions. You can have a straight beam of light, but you can also have light that kind of bounces off of things in lots of different directions.
Oh, okay.
I mean, does that make sense?
I mean, that's kind of what happens in a rainbow, isn't it? It bounces off something and is no longer in a straight direction.
I mean, it bounces off of the backside of the raindrop. It reflects off, and that's a bouncing. Mm-hmm.
Yeah.
But even like light, like there's light on the wall behind me. There's light from the light that's up in the ceiling. It's bouncing off of the wall, and the light's coming forward this way so you can see it.
Mhm.
right? Well,
Yeah.
that can happen on a much smaller scale because the wall is like flat and a big surface. Well, in the atmosphere, like you said, they're gases. They're far apart. There's lots of space between them, right? We can move through gases really easily. Anyone who's on the podcast can't see this, but I'm like in a weird way, like waving my arms through the air in front of me. If you want to see me making a fool of myself, please join us on YouTube.
Please do.
But like gases, the atoms and molecules are much farther apart from each other. So it's not like
Mm.
they're going to bounce off of a surface. A lot of the light goes straight through, which makes
Okay.
sense. We can see the sunlight. It's not like the sunlight looks like it's blocked by something unless it's clouds
Yeah.
like us here in Seattle, right?
Yeah.
But so the light mostly goes through, but some of the light actually runs into some of those molecules
Oh.
and actually hits them and bounces off. But the different wavelengths interact with the molecules differently because the length of the wave is different. And so the ones that actually scatter most easily are the shorter wavelengths. They interact with those molecules more and are more likely to bounce off, as opposed to the longer wavelengths, which are less likely, and they're more likely to just keep on going and not interact with the atoms and molecules in the atmosphere. And so the blue light
Wow.
is more likely to bounce off of the things in the atmosphere. Again, it's not all of the blue wavelengths, because a lot of that's still making it down to the surface as white light. And that's why we can still have rainbows that have blue in them, right?
Oh, yeah.
Because if
Mhm.
none of the blue light made it, then rainbows wouldn't have any blue in them because it would have
Yeah.
all scattered out before it made it to us. But some of it does actually bounce off of those molecules, and it's the blue that does it the most. And because then it's bouncing in every direction, that means even though the sun is in one spot in the sky, that blue light is bouncing all over the place, all through the sky. And so, and it's coming, and obviously the sun is coming from the sunlight is on a whole half of the earth, right? It's not just it's not like a laser beam
It's
directly
not a
below the sun.
spotlight.
Yeah, exactly. Right. But so the sun actually its light is scattered. And so everywhere we look, when we look up to the sky, what's reaching our eyes is more of that scattered blue light than anything else. And so the sky looks blue.
That is so cool.
It is cool.
So is the water blue because it's reflecting the sky?
So here's the next piece with the water and the sky. I used to think the same thing, by the way. I remember sitting in college in my meteorology class, and the question came up, why is the sky blue? And I leaned over to the girl who was sitting next to me. It's like, well, because it's reflecting the ocean. Because I thought I knew. I was wrong. Right? The
Yeah.
reason the ocean is blue is a similar reason to the reason that the sky is blue. Because the sunlight is actually and it's not quite the same scattering, but it's a similar interaction with the water molecules, because there's water in the atmosphere. Part of what's doing the
Oh, yeah.
scattering, it's not just water, but part of what's doing the scattering is water in the atmosphere.
Hmm.
I don't know, have you ever seen a glacier when you went on your cruise to Alaska where you didn't get to see the northern lights? Did you get to see a glacier?
Yes.
And when you look
Yes.
at a big glacier, especially if you're looking from the side, it has a
Mhm.
blue tint to it. Have you noticed that
Yes.
before?
Yeah,
It's the
totally.
same thing because water actually can do some of that scattering. You mentioned water is clear. And if I had like a glass of water, I could show you that water looks clear because there's not enough of it to do enough of the scattering. But when you
Oh.
get enough of it together, you can have some of that scattering. And there is some reflection between the blue sky and the surface of the ocean. So it's not that there's no reflection that happens at all, but that's not what gives a lot of it its color. It's that same scattering that happens. And the blue light, again, scatters more easily than the other wavelengths of light
Wow.
because it's a shorter wavelength.
That's really cool.
Yeah. And then you mentioned the sun is yellow, and the
Sunshines are yellow.
sunshines are yellow. Yep.
Mhm.
And they do look more yellowish to us, but our sun is a white star. And the reason it looks somewhat yellow is because a lot of the blue light has been scattered away from it. So it
Oh,
kind
it
of
keeps the
tints a
warm.
little bit towards, towards the warmer colors. Now, it doesn't look like yellow usually when we look at it, right? But it looks like it has more of a yellowy tint than just a pure white.
Yeah.
Yeah, and that's because of some of that scattering that's happened.
Wow.
Yeah.
That's really cool.
So do you think that's an optical illusion?
I mean, yeah. I don't think it's an yeah, I mean, it is an optical illusion because all of that is still how our eyes are taking it. You're right, but there's a real thing happening. So it's not just an optical illusion.
Right. Right. Because I think
Yes.
technically an optical illusion is something that is not at all happening, but our brains tell us is happening.
Yes. Yeah.
Yeah. And now it's time for Cheryl's favorite part of every lesson, the quiz.
Boo.
Yay!
My favorite part is where we draw sunshines.
I mean, you're welcome to draw sunshines on your quiz if you want to.
Okay. I will in my mind.
Okay, great. First question. Which colors have the shortest wavelengths and which have the longest wavelengths?
The cool ones have the shortest and the warm ones have the longest.
Can you give me an example of a cool color and a warm color?
Well, I think black is a pretty cool color, but I'm pretty sure you mean a different definition of the word cool
Mm-hmm.
than what I'm thinking of. A cool color is green, blue, and purple, and a warm color is red, orange, yellow.
Okay, great. What happens to sunlight when it goes through our atmosphere?
Well, some of the wavelengths bounce off things, and some of them not so much.
Okay.
So the longer wavelengths just kind of sail on through without a care in the world. And then the shorter wavelengths just bounce all over the entire sky. And
You said they bounce off
that's why we see
things.
them.
What are the things?
Gases.
Okay. I will accept gases. Okay. Why does the sky look blue and not green or yellow?
Not green or yellow.
Mm-hmm.
Do you mean green or purple? Or do you actually mean green or yellow?
I mean,
Or you
also
just mean
purple.
any other color?
Any other color. Yeah. Why does it look blue specifically?
Because the blue wavelengths are the one bouncing around the most.
Yeah.
So that's what we see.
Wonderful. Yep. Great. And what causes the ocean to look blue, and how do you know?
Well, the same wavelengths also really like to bounce off water. And when there's enough of it, it goes real crazy and gets all bouncy. And when it's a little bit in your hand, there's not quite enough for it to go bouncing around. So then we just see clear. And then maybe also sometimes it reflects the sky,
Part a little bit.
which is what I would think on like a dreary day. I guess there's also less sunlight. I was
Mhm.
going to say the water looks kind of dull,
It does.
but there's also less sunlight. So
There
it's like,
is.
okay.
Yeah.
Yeah.
Yeah. Because you're right. When it's really cloudy, the water looks more of kind of a dark gray with maybe a bluish tint to it,
Yeah.
but it's still a darker gray, which you're like, well, it's reflecting the clouds, which you could make that argument. A lot of people think
Yeah.
that. But also the clouds have filtered out so much of the sunlight.
Yeah.
So, yeah. All right. Last question. You ready for this one? It's a little bit harder.
Yes.
That was not confident. If you were on another planet,
Oh.
do you think its sky would look blue? Why or why not?
I think it would depend on if that planet had the same composition of atmosphere as we do.
Okay. Tell me more.
Because I'm guessing that different gases or different vapor or different things like
Mhm.
that in an atmosphere might reflect different wavelengths. It's a
Different,
possibility.
different than.
And then ours.
Okay. In which case, what would that result in if they reflected or scattered different wavelengths than ours?
A red sky. I don't know. It depends on
But a different
what
color.
was possibly. Yeah.
Okay.
Yeah.
Yeah. Great answer. See,
Yay.
look at you. You're always so scared and you always do so well.
That is how I live my life.
So scared.
And then I end up being fine. And I'm
Yeah.
like, oh, I was fine.
Yeah. Awesome. Well, now you know the answer to the question. And you can impress people with like, yeah, no, I know why the sky's blue.
Yeah. And I can travel back in time to Ryan in school when he whispered to that girl, surprise, that was me traveling in time.
No way.
And I'm like, psh,
But you didn't correct
call
me.
yourself a scientist.
You didn't correct
No,
me.
Well, until we alter history.
Oh, okay. Okay. Gotcha. You haven't done it yet. I see.
Well, I just learned it.
Okay. Alrighty then. Well, unless you've developed a time machine, we are out of time for this lesson. So why don't you go ahead and pack up your stuff and get ready for my closing remarks. You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.